Good evening, everyone. Thank you very much for making our time to, join this session. I'm pretty sure many of us might have been seeing all the designs and hints and updates and teasers about what we have in plans for the community. I think many of us might have seen or gone through the repository already. I mean, we have contributors already working on the repository that we have designed for us, right? And then basically the purpose of this info session is to um, clarify the reason why we're doing this, what we've identified, and why we are trying to do this to help the community get started in open source. And then in the course of this session, we'll be introducing you to all the projects that we have in plans, introducing you to Hacktoberfest and open source first, of course, and then how you can contribute to the different projects and get started in open source. And if you're experienced in contributing to open source, then this is just a way you can actually further that experience to get involved in something that the community is doing together to actually build definite solutions that we hope to make good impact in the long run, right? So before we get started, I'd like us to drop in the chats what you do. So whether you're a data scientist or you're a machine learning engineer or you're a writer or a data analyst or you're a designer, anything you do or whatever you do, if you don't mind, kindly drop in the chat session so we can have an overview of everyone that's on the call and know how we can carry everyone along. I mean, this challenge is open to everyone, to be honest, as you've seen from our posters, right? So if you don't mind, kindly drop that in the chat session. Hey, um, Tim Lane said he's a student and also a Python developer. Let me put it as that. Thank you. I'm also a Python developer, but I do machine learning. So I think Python developers are mostly associated with backend, though, I guess. So I mean, you can still write Python. So I'll say a Python dev. Um, Vera says she's a data scientist. Dion, software developer here. What language do you write? Sorry, Odion. Oh, great. Python. I mean, many of us write Python. That's nice. Um, oh, Ibrahim says he's an AI engineer. Oh, you don't really have to go ahead to rate yourself. I mean, we are all learning in one way or the other. So whether we are experts, we're still learning, or whoever is an expert or a beginner, we are still learning. So thank you for that. Um, Data science, technical writing. Oh, that's nice. That's from Eniola. Okay, Ikma says she's an ML engineer and technical writer. Since we have a lot of ML engineers on the call right now, it is really, really nice. Thank you everyone for joining in. Um, so firstly, right, I would like to introduce you to what we'll be talking about today. So first, we want to explain or talk about what open source and Hacktoberfest means for data scientists, machine learning engineers, and other data professionals. I know everybody has their own, let me say, conspiracies or ideologies about what open source is and does it really mean anything? Does it really add anything to you? And for data practitioners, I mean, oftentimes we don't really see many, things to contribute to as let me say, data professionals as a whole in the open source realm, basically. So would all share our opinions on this. Um, so I would like um, check. Ajibola, right? Ajibola, can you hear me?
Yeah,
Yeah,
I
I, I can hear you.
that's not
Okay,
I
great. So
Is it
I would like you to share, if you don't mind, what you think about open source and Oktoberfest, and what do you think it means for data scientists as regards your experience with, contributing to open source as a machine learning engineer. I know you're a machine learning engineer focusing on computer vision. So I don't know, what has your experience been and your view about open source, if you don't mind sharing, I mean.
okay? Let me just be brief. So I believe that open source basically allows different engineers from all over the world to collaborate and to bring into reality whatever projects that could be worked on, right? So okay, so the traditional way of development is, oh, there's a software engineer, a machine learning engineer that thought of an idea and he wants to build every part by himself, right? But open source is just this platform that allows each and everybody to add their source, right, to a particular project. So there's a project, but different people know how that different engineers have their flavor, right? Open source allows like these flavors from different engineers to be uniquely blended to give out like an output that would make sense, right? An output that just one person could have not written, right? So it's always an opportunity to open source is just always an opportunity to learn, right? So when you contribute to open source projects, you have the opportunity to see, okay, how do other developers think when they are faced with a particular problem? How do they tackle it? Do you understand? So open source basically is always an opportunity to learn, to see a problem from the lens of other people, to see how to code up a solution from the lens of other people. So I would say that one of the things I look forward to in any open source challenge I find myself in, or open source development environment I find myself in, is, oh, what can I learn? How can I better my own workflow? What processes could I integrate into the way I currently work? And do you understand? So I mostly focus on the learning aspect and also trying to like contribute my 2 cents. So that's all I can say. Thank you.
Wow, yeah. Thank you very much, Ajibola. That was pretty detailed, right? So, I mean, one thing I majorly picked out is always open to learning, always open to learning. So, open source basically is a major, I mean, from Ajibola for him, yeah, it says it's a major platform or a major avenue for him to learn how other developers think and how he can improve himself. I think many of us, with our experience, we maybe checking Stack Overflow for answers, or maybe with the advent or the popularity of ChatGPT now, maybe to put in our codes or ask questions and stuff to get answers. All these result from open source, to be honest, right? The data that you train on, most times they are available on the internet. If everybody was keeping those information to themselves, you won't really have access to it. If developers were not answering questions on Stack Overflows, you won't get answers to your questions. If people were not discussing on their GitHub repos and somebody's raising up an issue, another person is solving it, I mean, you wouldn't really know, okay, can I do this with this code? Or maybe one company, or let me say, for example, Scikit-learn, right, builds their module now, or their library, and then there is no documentation, right? How do you know how it works? So basically, I would say for me, anything that is in public, right, is open sourced in a way, right? But then when it comes to specifics and technicalities, then yes, you might say, okay, this is what open source is and this is what open source isn't, right? So, but the major thing I picked out from Ajibola is that always be open to learning, and I think it's something I try to apply myself. Thank you very much, Abibola, for sharing that. Um, I don't know if Josiah wants to share something with us. Josiah, are you here? Okay, I don't think Josiah is with us. Um, Odion, I think probably you have some experience with with open source. So let me say a lot of experience with open source. I don't know if you want to share one or two things that I think um everyone can benefit from.
All right, so we've already said virtually everything, so I'm just going to keep it short. But open source basically means it's open to the public, so everyone has access to it to use and to develop. Now, the entire idea of open source is to reduce the time to development. So, in the sense of making use of open source, um, it allows people to use technologies that have already been built without having to build them from scratch again. So, you are solving problems faster. And in terms of developing projects in open source, it increases the speed at which projects are developed because developers from across the world can contribute to projects and development is faster.
Thank you very much, Odion. That's to be honest a very good summary of how open source works. Everyone can contribute. You definitely will not know everyone that's contributing because it's a public space you get. And then everyone has different ideas, an approach that you might be thinking of. Someone might come up with a different solution and then it outperforms what you have done. From that process you've learned, and from that process, the project you're working on is also moving forward. So that's the beauty about open source. I think Josiah is back here now. I saw your hand. You can go ahead and unmute and speak.
Okay, yeah. Good evening, everybody. Yeah, sorry about that. I was not able to talk at that moment. So yeah, okay, my own idea of open source is just like maybe built on what everyone has been saying. So I'll just say like maybe the beauty of it. So the beauty of it is that like most of these technologies you see, so either complex or maybe difficult or not. So you get to see the codes. Yeah, you can see like the codes and even the people that built it, like those that we call the contributors, and like everyone that is supporting the community. So like that's one of the things that amazes me. So it's just like the code base of these guys are like it's very open, and you can replicate it. You can make adjustments. Like at least the few that have maybe encounters with like the ones I've seen online, you can see people can like open like issues like maybe there's a let's say there's an error or something is not working properly, so it's very easy for someone to like just like put it out there that okay this is not working properly, and you just see another person just take it up that okay they want to solve this issue. So it's like everybody is building together. If we can call it like okay, let's say we can call it like the ant strategy. Everybody is just working from different places, building together for just a certain goal. So and I think that's what we are also trying to do at the moment. Yeah, so that's my idea. Thank you.
Okay, thank you very much, Josiah, for sharing that. I also know you're data scientist, or I don't know, probably you would like to be called a machine learning engineer more. So I wanted to ask your experience as regards contributing to open source as, let me say, data professional. How have you found it, and what do you think about it? Like the opportunities available and things like that.
Okay, so I've not really had much of contribution. I think the one I did maybe recently is more of writing. Yeah, to like that, but that one is more of machine learning. Talking about one open source AI quality library like that. You can check it out. It's called GSCAD. So I think that's the one I know I have like like I did something on. So I think that one was like to get if a model is biased or not. So and it's really interesting. You could like how I say it, you could easily discover if something is biased or not. So that's one of the encounters or one of the stuff I've done with like open source. You can I don't know maybe I can write it out. Let me just write that.
Okay, yeah, I heard
Yeah.
you, Josiah. Thank you very much for sharing that. To be honest, yeah, most of the um, let me see, open source opportunities that I've also seen as related to maybe data that I could contribute to were as regards writing. Last year, Hacktoberfest, uh, one of the first things, like let me say, first repositories I contributed to was one that was asking basically like a glossary of um, tutorials, or let me say resources that could help you. So like there was this section where they had a glossary of learn AI, right? So I just contributed one of the tutorials I took that I found very interesting, and then it was made. So like personally for me, right? And I think in general, we all share this idea that open source for data professionals in general hasn't been like really smooth, to be honest. You get so like most of the, I think you probably might have seen this on my Twitter and maybe LinkedIn already, that most of the you know projects or you might see as regards data, or let me say machine learning or data science, right? Would be maybe Python packages, right? So I don't know if you know about IV and what they're doing. So they're trying to like, bring PyTorch, TensorFlow, and JAX under one hood, right? So where you can use the same syntax to build your deep learning model. So you don't need to know TensorFlow and know PyTorch and know JAX. Once you know IV, you can build um, deep learning models with the same syntax, right? So imagine a repository like that. If you go into a repository like that, I think if probably you've not worked on such solution before that time, or maybe you don't have work experience as regards building such solution, I don't think you'll be able to relate to anything in that repository, to be honest, right? So most of them are usually very, very advanced. Some of them involve coding in backend with C++. I mean, I think many of us know that most deep learning models are powered by C++ in the backend because of the speed of C++, right? So things like that, if you don't have the full experience of it, you definitely wouldn't relate to it at all. And then, while learning Python or learning machine learning, these things that actually are applied in, let me say, in full scale AI solutions are not really taught at those beginning levels. I mean, I don't even think you would encounter them in your PhD levels. Probably, maybe if you do a PhD in AI or machine learning, but if you do a PhD in data science, you definitely wouldn't really be taught maybe things like C++ and stuff. It would all be like maybe more practical theory like statistics and, applying some statistical approaches for stuff, deep statistics work, right? But then if you look into these repositories, they've gone beyond that, to be very honest. So what we are trying to do, right? So we have other ambassadors on the call, right? What the Microsoft Learn student ambassadors of Nigeria are trying to do, right, is to create a repository that all of us can relate to. A repository all of us can relate to, where um, from your tutorials, you probably have worked on classification models, or you've started a deep learning course and you've done this Cummins popular TensorFlow, um, cat and dogs classification, or you've worked with a learning models to build a regression problem to predict stock price or something. This repository is something you would definitely relate to. So I'll just open it down, right, so that we can all see, and then we'll move on to exploring. Let me zoom out, get up. We'll move on to exploring um, the different projects we have for this challenge, right? So permit me to, yeah. All right. So basically, this is what we have now. Um, I think we can all see my screen. So we have built this up to a level that we can all relate to, right? So you, in your own time, I'll drop the link to this in the chat, right? So in your own time, you can choose, right, to go through this repository, or maybe you can actually do that even within the call, depending on you, right? But then this is the repository that we have, right? And we'll be exploring all the different projects and how you can actually contribute to this project as a data scientist, a machine learning engineer, a writer, and a designer. So this, I mean, some of these emojis that you're seeing here were not done recently. We didn't do that ourselves. So someone actually contributed to it. It's one of the pull requests that was matched, and you can see our current contributors here. So, right, we're going to establish a leaderboard where that keeps track of all your contributions. So when you make a pull request, we're going to explain all that. Someone is going to walk you through how you can make pull requests, how you can make your first contribution. We've also linked a resource, right, that you can watch to make your first contribution in the contribution guidelines here, right? It was done by Digital Ocean. It's something I actually made use of last year to get myself more familiar with open source contribution as regards, making pull requests and things like that. All that will be discussed. So let me just brief you about the different projects we have. So the first one is an image classification project where we'll be classifying between bungalows, story buildings, and high-rise buildings, right? And then we'll be deploying this project with Streamlit. And the data collection process is also open source. So, right, we're calling for people to contribute to, you know, take pictures and then upload to the repository. So you don't even need so much expertise to contribute to this repository. So if you're never going to contribute to any code at all, you can contribute to this by giving us or helping us with gathering data to train this machine learning model. So we have some images here at the moment of story buildings and bungalows, right? So this is an overview of project one. And then definitely, when it comes to image classification, you're leveraging deep learning. So whether it's TensorFlow or PyTorch that you're comfortable with, that's fine. But we've also given a starter notebook of in using TensorFlow of how you can contribute to this project. So soon after this, Majibola will walk us through how you can actually introduce you to deep learning, introduce you to image classification, and how you can actually contribute to this project in terms of code and modeling, right? So project two is a speech translation project where you can upload your audio in English language or typing your text in English language and translate it to either Yoruba, Igbo, or Hausa. So now we're trying to localize this project to Nigeria so that it's something that can actually be used in want to build solutions that can be applied in real world scenarios around us, right? So like in localities where there are huge language barriers, in schools where students are struggling to understand their teachers speaking in English, these are some of the projects or solutions that can be used to help bridge that career. So I mean, bridge that gap you get me? So we'll be leveraging Azure AI services. I myself will walk you through how you can leverage the speech service and the translation service in Azure. And we'll mostly be working with scripts. The deployment will also be done with Streamlit. So we're trying to make it be around Python so that every one of us can contribute. In the long run, we'll see how we can also open source this to maybe front-end web developers that might want to help us build a more elaborate web portal for the deployment. Or like at the moment, what we're going to be majoring in is a Python for deployment, which is using Streamlit. So for our project three, what we're going to be doing is a prediction of the GPA of year one Nigerian students, right? So based on your history, right? Maybe your jam score, your work, your reading patterns, maybe your financial status while you were in year one and stuff like that, to kind of help create a solution where people can, okay, project the way they're going, right? So based on maybe say your first semester, first 3, 4 weeks, 5 weeks, and you can see maybe you feel like you're struggling or something, right? Based on our solution to compare yourself with other people's scenarios, like hopefully we get a lot of data inputs. We have a form that has been linked here that you can fill, right? So if you're a Nigerian student or were once, I mean, or once a Nigerian student and at least you did 100 level in Nigeria or something, you get this is something I believe you relate to. You can help us fill this. There's also an issue in the issue section in the repo, so you can check that out, right? And fill the form. Though definitely we won't be able to track this because we want to make it anonymous, right? So this form is anonymous. Once you fill it in, it's not asking for any of your details, right? So we won't be able to track it and say you actually made contributions. But then you definitely know that you have contributed to making this project successful by contributing your own personal data for this project. So with this solution, students can be able to project what they have in mind, I mean, what they think they can achieve at the end of their first year, right? Based on how things are going currently for them. So it's definitely something you would want to be part of. We also have a starter notebook here that Felix will walk us through. I don't know if he's on the call, but if he's on the call, um, he would walk us through that. And then coming to the prizes, right? We're planning to do, or we have in mind, right, to do a weekly leaderboard. That's basically what we're gonna do actually. A weekly leaderboard of top contributors, right? And then at the end of the challenge, we are going to award the best contributor or the person with the most contributions. And then we're also looking out for impact. So if you see an error in the repository or something, don't just look for that alone and make a pull request or something. Try to make sure that your contributions are meaningful, right? So we're really measuring impact, right? So it's not just spamming of contributions to make up numbers. You get me? Right. So that's basically the summary of the GitHub repo. Then we'll go into details on how you can contribute to each project. So for our prizes, we have LinkedIn vouchers. I think many of us might be building our profiles on Twitter and LinkedIn, right? So we have LinkedIn premium vouchers for a year, which gives you to so many exclusive things you can do with LinkedIn, right? Like your email, you have 45 right? 45 email credits per month, right? So you could use that to message recruiters that are not connections with, while doing your job search and stuff like that. And it also makes your profile even more visible. You can do a lot of things with LinkedIn Premium, to be honest, right? And then for the final price, we're not going to mention that yet, but then expect that it should be something huge. So thank you very much for sticking with us up to now. Ajibola will be giving us a full overview of Project One and how you can get started with making a meaningful contribution. Ajibola, are you on the call?
Yes, I am. Can we hear me?
Yes, I can. I can.
Okay, so good evening, everybody. Good evening, everybody. My name is Ajibola. Now take us through a quick walkthrough. I would have loved to actually demo with some examples, but then I'm currently being hindered by a lot of factors. So please just bear with me. As someone would help me navigate through the screen. So please just bear with the walkthrough. But then I believe that once you open this starter notebook is actually very explanatory, right? And with whatever I would be adding now, I believe that it should get you on your way. Um, so um, so basically, like it's written there, welcome to the image classification starter notebook for Hacktoberfest competition. So this is the project one, right? Project one basically seeks to build an image classifier. So what is an image classifier? Image classifier is just being able to so let me give a quick example. So the same way when I see a car, right, as an human, and I can say, okay, this is a car. And when I see a toy, or when I see a building, and I can immediately identify it. Or let me use the most popular one in the computer vision space, which is the cat and dog. So the same way I can see a cat and say that, oh, this is a cat, and I can see a dog and say this is a dog distinctively, right? That is what we are trying to mimic in the computer, right? Which is the whole essence of computer vision. So image classification is a field under computer vision, which seeks to, like the name entails, give computers vision, to make computers see, to make computers make sense of image data. So I believe that, in case we do not know, images that we see on our screen is made up of numbers called pixels. So the same way, I know some of us might be familiar with this thing called RGB, primary colors, RGB, red, green, blue, red, green, blue, right? So images that we see is just made up of values that mixes this color together. I'm sure when we're in primary school, we usually do, okay, when we add two primary colors together, what are we going to get? We get secondary colors, right? So if you say what is red plus green, can someone just put it in the chat room that what is red plus green? So when we add red and green together, what do you think we'll get? What do we think we'll get? Yellow. Exactly. So red and green should give you yellow. Let me confirm, because I think yes, it should give you yellow, right? Let me just quickly confirm, because I'm not a color expert myself. But then I believe that yes, you are correct. Yellow. So red and green will give us yellow. So basically, I'm not going to go into the details of how images are being seen. But then for you to understand what computer vision is, you have to first understand that every image you see is just a representation of numbers, right? So how these red, green, blue images are being mixed together, that's how we see pictures, right? So to the computer, it's just a bunch of binary data, it's just a bunch of numbers, right? But to we humans, we see the images as they are. So how then can we now make computers understand this particular image? Is there some sort of way to be able to distinguish these numbers from other numbers? Now, why am I saying these numbers? Because I already said an image to a computer is just number, right? So is there any way we can distinguish this set of things from each other, right? So that's what brought the advent of computer vision, right? So normally before, without things like neural networks or machine learning or AI, it would have been a pretty difficult task. We could have said, okay, for us to create an image classifier, what we'll do is image classifier that classifies between a cat and a dog. What we'll do is we'll check, does the image have whiskers? So if it has whiskers, we can say, okay, it's more likely to be a cat. So we could just use some conditional statements. If the image contains a whisker, then maybe most likely it's a cat. But even dogs, I believe that, I'm not so sure, but quick question, do dogs have whiskers? But anyways, is the image smaller than usual? If yes, maybe it's a cat. Is the image big or something? But then you see that there are always going to be errors. There are always going to, because if you want to use the fact that, okay, images that are smaller will most likely be a dog. There's some dogs like Chihuahua that are small, right? So you cannot just say that, okay, this is going to give us a cat all the time. Do you understand? So trying to build image classifier systems with conditional statements has proven to be inefficient. That's proven to be the result is not the result is not really the best. The result is even far from being the best, right? So in the advent of deep learning and in the advent of machine learning, it made it more easier, right? It made things like this easier. So deep learning basically is a field that implements what they call the neural networks, right? So in deep learning, there's something called neural networks, and neural networks are mostly used in cases like computer vision. So yes, so for a task like this image classifier, we could actually go ahead with using some normal classifier systems that we are aware of, right? We could do that, but then neural networks and computer vision usually give a good result, especially in cases like this. So neural network. So I'd advise that you could proceed with what is already here. You could use the neural network architecture that was created with TensorFlow, or you could try other means. You could try other classifiers to see. Okay, you could try XGBoost classifier and try and see if you could you get create something from it. Do you understand? So basically, like I said, images are just bunch of numbers, right? So we are faced with the task that, okay, we want to classify between building types, bungalows, high-rise, and story building. How can we do this? First of all, we need our data, right? We need our data. Data is very, very important, right? We cannot just proceed without the use of data. So if we need our data, that means we have to start looking for, okay, where do I get my data from? How do I get my data? And this is usually the problem with most machine learning or neural networks or deep learning problems, especially deep learning, because I didn't really explain what's deep learning. So deep learning means, in deep learning, what we try to do is that we use something called neural networks, like I said earlier, and neural networks are inspired from how the human brain works. So basically, in your head right now, for you to understand everything I'm saying, there's some things called neurons, right? And neurons are billions of neurons in your brain, and these neurons get fired up to pass information from each other. So there are neurons that are connected by something called synapses, right? And they transfer information and signals from one part to the other. So for you to even understand all this, what I'm saying, and for me to even think of all these things, there are a lot of activities going on in my brain. That's why when you see all these MRI scans and all these things, these are just activities going on in your brain. So some scientists thought that, okay, could we mimic this behavior and put it in a computer? Could we create a system sort of that could actually mimic this firing up, this transfer of signals from one point to another? And yes, they did something called neural networks. So neural networks are basically a bunch of artificial neurons that are stacked together to transfer information until we get an output. So basically, informations are passed through something called the forward propagation, and errors are taken. So the reason I will not be able to give the specifics right now because it's not a class to explain in depth what deep learning and neural networks are, but then just know that neural networks is a system that was created to be able to help us with this, right? So let me just give a brief analogy, or not analogy, or a brief explanation of how neural network works. So basically, say we have an image of a cat. Say we are trying to build a cat and dog classifier, and we have an image of a cat, right? Please just bear with me and try and imagine this. So we are trying to classify between a cat and we have between a cat and a dog, and we have an image cat, right? So if we were to use a supervised learning approach, that means that we know the output from the beginning. So basically, once we pass the image, we already know the output, right? So basically, there's going to be a model training sort of where we pass in all these images, right? And we ask the system to predict what it thinks the output is. So say I pass in the image of a cat and it says that, oh, this is a dog, right? Or something like that. And since we already have the output that it is a cat, right? Then we try and create a system of feedback in the sense that, okay, how can we measure the error? How can we measure the error in the prediction? Do you understand? What did it do wrong? What can we look for a way to quantify the difference between what is predicting and what is the actual value? Do you understand? So it is this system put together that this system of error and all that put together that is called backward propagation. So if you want to learn more on this, just search Google backward propagation. So backward propagation plus forward propagation is what makes up the neural network in essence. So basically, I try to predict something. So just imagine a baby growing up, right? Imagine the neural network is a baby, and it's when it's small, when a baby is small, a baby might not exactly know um, what a dog is on what a dog is not. Do you understand? As he's growing, you'll be able to maybe tell his mommy, mommy, is this a dog or a cat? So if the mother tells it that, oh, let's say they see a dog, if the mother tells it that, okay, this is not a dog, but this is a cat, the baby will store it somewhere in his head, right? So if the baby is faced with an image of a cat again, so he can say, oh, mommy, is this a cat now? Then she say yes. So in his head, he knows that, okay, this is a cat, right? The feedback system, right, in that case would be like, say, he's predicting that this is a cat and his mother says this is a cat. So the error there is 0. Do you understand? So basically, that's just a mimic of what a neural network is. So not to bore you with all that talk, let's just go straight into the starter notebook. Please, Samuel, can you go back up? Let's just look through. Samuel, can you go back to the beginning of the code?
Yes, I'm there now.
Thank you. So yes, for this, we'll be using TensorFlow. Of course, you could use PyTorch, and like I said earlier, you could use other classifiers that you are comfortable with. But then I just used one of the most popular options out there, TensorFlow. While I'm waiting for, okay, yes. So yes, like every project you'll be doing on machine learning, you have to first import your libraries, import your OS, import your NumPy, import your TensorFlow, TensorFlow, import your image data generator, and import pandas. So I don't think I used pandas here, but I just imported it just in case some people might try and create the data and put it in form of a data frame, which is not so necessary, but I just imported it, right? So the next part is to define constant, right? So it's always important to do most of these steps, right? Just do it one time for constant that you know that you'll be using later, right? Now, like now, the image height, the image width, the batch size, and yes, the batch size basically is going to be used for our image data generator here. Then we are defining the paths for the data. If you check the repository, you'll see that there's a folder called data. So yes, and the class names are bungalow, iRise, and story building. These are also, so once you open the data folder, you'll see these subdirectories there, the bungalow, iRise, and story building. So yes, this data generator is common to the TensorFlow, right? You notice that from the earlier code, we imported it from TensorFlow, there's Keras, right? So what it does basically is that it helps us do some bunch of image processing on the go, right? What do I mean by on the go? So basically, once you just feed it, okay, this is the source for the input data, right? This is the source for our training data. This is the source for our validation data, right? Then all you have to just tell it is that, okay, this and this is what I want you to do. So now in this data gen, this space that there is data gen, image data generator, rescale equals to 1/255. What are we doing there? Basically, we are trying to normalize the pixels. So I said something about RGB values. So RGB values ranges from between 0 to 255. So R in the RGB ranges from 0 to 255. So say we want to get a perfectly red picture, what will we do? Just put 255 for red, green is 0, blue is 0. Do you understand? So if we want to do the yellow, that is red plus green, so we just have to do 255 red, 255 green, and blue is 0. Although yes, you don't necessarily have to set it to 255 to get yellow, but then if you want to get the sharpest value of yellow, you just have to do that. Do you understand? So normalizing is actually going to help our neural network learn better. Do you understand? So we are normalizing it by of course, if you normalize it, you're going to get values between the range of 0 to 1, right? 0 to 1. Why? Because our maximum value is 255. And if we do 1 over 255 times 255, that's just going to give us 255 over 255, which is 1. Do you understand? So the maximum value we are going to get is just going to be 1. And trust me, once you normalize all the pixel values, you're still going to get the same image, right? You're still going to get the same image. You are just rescaling it. You're just, like I said, normalizing it. Then validation split is just a parameter telling, okay, how much data do you want to use to validate or to test our model? So this is just 0.2, which is 20% of the data. So that means for the train, it's going to be 80%, right? So feel free to tweak these values, right? This notebook is your canvas. I mean, just do whatever you want to do it. There are a lot of more options, right? So this data gen actually gives us opportunity to tweak our data a lot. So say, which is mostly the case for all these projects, right? There's not always usually enough data, right? You see models that are very good like ChatGPT actually have been trained on billions and trillions of data. Do you understand? That's why it's that good, right? But then for us that don't really have much data, this data gen actually gives us the opportunity to be able to do something called data manipulation, right? So basically, we can manipulate our data in different ways. We could flip it to in the x-axis, we could flip it in the y-axis, we could shrink it, we could drag it, we could do a lot of things to it, right? So basically, why are we doing that? We are doing that so as to get more data sets. Do you understand? So let's say we have only 50 images and we want to train a computer vision classifier that is very accurate. Of course, that would be really difficult, right? With just that amount of images. But then with data gen, we could actually stretch, do a lot of things, flip the data, flip all the 50 data twice and flip it. So that will give us like 150 images. Do you understand? So that's why I use this data gen particularly. I could have used the OS module to try and navigate through the paths and try to manually tag my label and everything. But then I use this because it gives us the opportunity to be able to learn something new in case you've not used this before. There are also other ways to go through this. Like I said, it's left to you. So once you do this, and the good thing again about this data gen is that it automatically tags your data for you, right? You get your label and you get your actual data, right? It helps you do that. And now in this case, there are 3 labels: bungalow, high-rise, and story building. So of course, it can be tagged in the sense of 0, 1, 2, where 0 represents bungalow, 1 represents, say, high-rise, and number 2, story building. Do you understand the point? So if we did not do it this way, we would have had to create our labels and we would have had to tag it and we would have had to shuffle it using the random model. Do you understand? I believe that you could do that if that's the one you are comfortable with, but then this one helps you to take away most of that. So that's why I use this, because one of the reasons of this hackathon again, and one of the Hacktoberfest rather, is to eliminate as much work as possible, right? To make it as beginner friendly as possible, right? So as to make you to be able to use it as fast as possible. So the model architecture. So basically this one also, I've not tried it, right? But then it should work, right? Don't forget, this starter notebook, the goal is not to give you the very best model out there. And trust me, you could actually add more layers, you could use less layers and get better results. So that's left to you. That's one of the fun things about this project. You can experiment, right? I mean, you could add more convolution conv layers, right? You could just add like 5 more conv layers, then do the max pooling and the you could even use flatten more. That's left to you, right? You could just try it, right? But then the thing that would not change if we are using this TensorFlow is the last layer, which is the dense layer and the 3. So the 3 there is just representing the output. Don't forget that we have three things we want to classify between the bungalow, high-rise, and story building. So that's why we have 3 there. We wanted to classify between 10 things, we write 10 there. And the reason why our activation is softmax is that softmax gives us like so it gives us something like, imagine a list of probabilities, right? So the one that has the highest value is one that is being classified. So say we have like so say the list is between bungalow, high-rise, and story building, where bungalow is 0, high-rise is 1, and story building is 3. So if we add our array to be something like 0.1, 0.2, and 0.7, note, first of all, that adds up to 1, right? Because it's probability. And of course, in this case, because 0.7 is the highest, that means the predicted value will be story building, because story building is the third value, do you understand, which is the maximum value. So that's just a way to interpret results you get. So you could use just a clue to get, I think it's even here, or just a clue. In case you do not get that, you could use something called np.argmax. Argmax will give you the highest argument that, so basically just give you the results, right? Give you the results. Yeah. Then we compile the model. After compiling the model, we train it with 10 epochs. So epochs basically are just 10 training cycles, right? So imagine 10 processes, imagine different processes where the story I gave earlier, the child asking the mother, is this a cat? No, it's not a cat. Then it goes back, is this a cat? No, it's not a cat. Imagine that 10 times. So that could be enough for the child to know that, oh, yes, I know what a cat is and I know what a dog is. Oh, mom, is this a dog? Oh, mom, is this a cat? So say 10 times. So there's this feedback system that is implemented every time. So in the child's eyes, in the child's mind, okay, a dog has a longer tail. So no, that's not a dog. Do you understand? So you could use 100 epochs. You could use 200 epochs. But then that's left to you. There are many more hyper parameters left for you to tweak and to tune, rather. So that's left to you. That's a skill on its own, trying to tune hyperparameters. And there's not always like the best thing to do, right? It depends on the project, it depends on the data, it depends on a lot of things. So just try tweaking it, right? Then evaluate the model. So don't forget that we did a validation speed of 20%. So basically, whatever model we built would now be tested on this 20% of the data that is available to us. So yes, and we get our test, then save the model. So you can just save the model, and I believe that we have to upload it. Someone will correct me on that. I think we are uploading the model, right? So you can just save the model. It will save it in form of a pico file, right? Save it in form of a pico file, then you would upload it, and yes, yeah. So that's basically it. Like I said, there's a lot of things that you could tweak. There's a lot of things that you can change. This is not a perfect starter notebook. This is not a perfect model, right? It's not going to lead you to the perfect model. The model architecture there is just like, should I say, placeholder, right? But then it's left for you to tweak it. It's left for you to change it, right? Just change the values. You're going to get something really good, right? So yes, so thank you very much. That's basically it. So don't forget, you can tweak it as much as you want. Don't be scared. And errors do not kill. That's one thing I realized. Errors do not kill. I think errors even make you better, because you know what not to do. So errors do not kill. So yeah, you could keep tweaking it, getting errors. You can try 1 million epochs. Try it and see what happens. Yeah. So yes, so that's just a word of advice. Please don't try 1 million epochs, especially if the data is very large. My laptop has hung many times before, because I've tried to do some things that I should have not done. Right. So please don't blow your laptop because of Hacktoberfest. Thank you very much.
Thank you very much, Ajibola. That was really detailed, and I think maybe many of us that might not be familiar with deep learning at the moment definitely have a solid foundation of how you can work around it, and work around this project and make meaningful contributions. Don't forget, even if you are not technically sound as regards maybe deep learning, you can contribute hugely to the data collection process by helping us take pictures of buildings and uploading them in the right folder under project one in the data folder. So we appreciate you taking the pictures in portrait format and an aspect ratio of 3:4. So probably when you pop up your camera application, you'll see one thing showing like a bracket 3:4 or 9:16 or something like that. Just change it to 3:4 in portrait, take a picture, and send. Upload to the repository. Thank you very much. Thank you very much, Ajibola, for that detailed explanation. I believe many of us already have questions on how we can actually contribute to this project, right? And other projects in the repository, how to set up your work environment on your laptop. Okay, if you want to work with notebooks, how you're going to do that, or stuff like that. So, Odion on the call will help us with that. So we will introduce you to how to get started with open source, how to make your first pull request, and then I would walk you through how you can maybe leverage Azure Machine Learning Studio for your modeling, or leverage um, Cargo notebooks or Google Cloud. So thank you very much. Odion, I don't know if you want to share your screen.
All right. Good evening, everyone. Thank you very much, Samuel. I'm just going to go ahead and share my screen now. Give me a minute.
In the community of the capital after the election of the 70s of the interested chapter of the union. And the Germany will Congress of Berlin commenced the raising operation by a demonstrate.
Hello, can you see my screen now?
Yes, I can.
All right. So we already run through what open source is all about, the importance of open source, and run through one of the projects. So now we're going to go through how to set up the project on our own local machine, and how to contribute and create a pull request. So first of all, we're going to go to the project website. So here we have the project. And then now we want to fork it into our own GitHub account. And over here, you can see we have fork here. Just go ahead and click that. And then we get this. Right now, I can't fork it because I already have that done already. So I'm just going to go ahead to the what I already have forked here. So now I want to move this. I want to clone this to my machine so I can be able to contribute from my personal PC. All I need to do is to copy the code from here. I just have to copy this particular website here, and then go into my VS Code. I assume that everyone has VS Code installed. If you don't have that, you can go ahead and install that. And then we'll go into our terminal. Currently, I'm in desktop, you can see here. So I want to go into documents. Since I'm using a Linux command line, I'm just going to say documents. That's to change direction to documents. And this is where I want to go ahead and clone. So all I need to do is type git clone, and then paste the website, which I already copied. And it's going to go ahead and clone that for us.
I'm sorry, Odion, do you mind if you can enlarge your window so it's a bit bolder?
Okay.
That's Command plus.
I have to.
Command plus.
Oh, that's not working here.
Oh, wow. Okay.
I'm not sure I can do that right now. Is it
Okay.
is it not visible at all?
No, it is just the terminal that looks like the text in the terminal is quite small, but I mean I think that's fine. I think the plus,
All
oh, the
right, all
plus,
right,
yeah, that's fine.
all right. So we have it cloned already on our PC. Now the next thing I want to do is to open it. So you go to File and then Open Folder. I'm going to go. I cloned it to Document, so I'm going to go ahead to Document and then open it from here. So we have the project cloned on our personal PC. So now, because we're working, like Ajibola said, we're working with like various libraries, modules, and packages. We want to have it packaged in a particular environment so it does not affect and cause conflicts with other parts of our computer. And then I'm going to explain why we need that. So to be able to create we're going to be creating a virtual environment since we're using Python. We're going to use Python to create a virtual environment. And to do that, we just have to open terminal, create a new terminal, and then want to create a new virtual environment. So to do that, we just say Python 3 -m, then venv. What this does is it creates a virtual environment. And over here, you can see our virtual environment has been created. Now let's give that a minute to load up. All right. So now we need to activate this virtual environment that has been created. To do that, we just have to, I'm using Linux, so I'm going to be using source. I think for Windows, it's just bin scripts that activate, but for Linux, it's source, then venv, that's the virtual environment, then bin, then activates. And what that does is it activates our virtual environment. And if you look over here, you can see that our virtual environment has been activated. Now we have created our virtual environments. Everything is set up. Now, the next thing we want to do is to install all the libraries and dependencies that have already been used in the project. And over here, you can see all the libraries and dependencies that have been used during the project. Now, to be able to install this, we just have to write Python. We'll use pip install. Pip install -r, then we'll type requirements.txt. I'm not going to be installing that because of time, but once you run this is supposed to install all the requirements for this particular project. Now, our project is completely set up and we can go ahead to make all kinds of contributions that we want to make. Now, if you look over here in my VS Code, you can see that we have a lot of files that we just added because of the virtual environments created. And we don't want to push all these files to GitHub because to be redundant and to be unnecessary. So all we need to do now is to tell GitHub that when we push our contribution, it should ignore our virtual environments. So I'm going to use that as my contribution. So all we have to do is to type virtual environment. So if your virtual environment is named venv, just go ahead and type venv here, and it's going to ignore that particular virtual environment. Whatever you decide to name your virtual environment here is what you are going to type here, so that GitHub can ignore. And you can see over here now the numbers have reduced. The only thing that we've changed now is our git ignore. Now I can see that's my contribution, and I can go ahead and commit that. Please let your contributions be more sophisticated than this, and more useful. So I clicked this particular plus sign to stage my the changes that I want to push to my GitHub repository, and I can type what the change was about. So I can say I updated the git ignore file. So I can go ahead and commit this now that I've done that, and then sync changes. So now what we just did now is that.
What does, okay, I think you're going to that. I wanted to ask what commit means.
All right, so what we just did now is that we moved all our contributions into our version or our own copy of the project. So now if we go ahead to back to our project here, this is our own copy of the project here. We can go ahead and reload this page, and we'll see that our branch is now one commit ahead of the main branch. So we've made an addition to our own project, and so it's ahead of the main projects that we are working with. So now we want to create a pull request. What's a pull request? A pull request is you are telling the maintainer of the project that, okay, you've made contributions, you want these contributions to be added to the main project. So we're going to go ahead and click this. And then over here, GitHub is going to check if there's any conflicts with your with the pull request you're trying to create. And if there are no conflicts, GitHub will tell you that you can go ahead and create a pull request. So I'm going to go ahead and create a pull request. And here you can give more details about the contribution that you have made. So you can just basically say added my virtual environment to the list of folders to be ignored by GitHub. All right, so we can now go ahead to create our pull request. And once we create our pull request, the job is done. So we're going to wait for the maintainer of the project to assess our contribution if it is of good quality, and then the maintainer of the project is going to go ahead to merge that pull request. And over here, if you look over here, you can see the commits that we made. And we can see that we updated our gitignore file, and then we can check the file changes. So we can see what changes we made to the file that we worked with, and we can see that we added the virtual environment file. So basically that's it. And over here you can see all the pending pull requests that's been merged. So yeah, thank you very much.
Thank
if
you
you have
very
any questions, please go ahead and ask now.
All right. Okay, so while you are thinking about your questions, I would explain. Thank you very much, Odion, for sharing that. That's basically how to make your contributions, right? So, I want to share how you can actually make use. I saw some questions in the chat about using notebooks on the cloud, right? So you don't load up your computer, right? So I'm going to explain how you can leverage cargo notebooks. I also try to explain how you can leverage Azure Machine Learning Studio and Google Cloud. So any of these three would work fine for you. Okay, yeah, would make that available in the repository. It's actually in the repository. If you go to the repository, you see contribution guidelines, right? Though it doesn't include you creating a virtual environment, but we'll add that up so that you can have a full scope of how to create your own setup to contribute on your local machine. Thank you for that question. So I'll go ahead now to share my screen. Okay, so here is the Azure portal, right? And if you're a student and probably you're just hearing about Azure for the first time, or if you're on this call and just hearing about Azure for the first time, so Azure is a cloud service that gives you access to so many things, right? So you have so many AI services that you can leverage in Azure. You can do developer operations with Azure, right? You can do Kubernetes, which is like containerization of applications. For those still a DevOps technology, right? Or machine learning operations with Azure. So many things you can do. You can store files. You have access to large space of storage accounts on the cloud, and so many other things that you can do with Azure. So you can head over to the portal and explore all the services that you have available. So But to actually work with notebooks, right? My go-to for working with notebooks is using the Azure Machine Learning Studio. So all you just need to do is click on plus, right? Click Azure Machine Learning, then you see the option for here, just under here, click create, and click this, right? Then let me increase my screen a bit. Okay, I think it's a bit small, visible. So now what you want to do is create a resource group, right? So let me say I create a resource group. A resource group is basically, just like it says, a container that holds related resources for an Azure solution. So let's say you're working on a speech service, on a speech service or translation service, you can just create a resource group that will contain everything that will have, I mean, of course, they will be at the same region. It's recommended to put them, their resource group and other resources have the same region and other things, so they can communicate with each other within that resource group. You get me? So let's say we term this October first. It is available. Okay, yeah, it is. And then we name our workspace image classification, for example. Okay, that is also available. You can select West U. West US is kind of far, so you can change this to East US. Select the region closest to you. So you can either select East US. For me, I mostly work with East US or West Europe, right? So we'll click East US here, and then click on review and create, and then wait for it to validate everything, and then you click create. So it's basically validating that all your settings that you've made are correct. So you create and then wait for deployment, right? So this will take you about maybe 2-3 minutes to fully set up, and once it's done, you can launch the Azure Machine Learning Studio to do whatever you want to do within your notebooks, right, on the cloud. But then we'd walk through something else, right? So while this is running, let me sign in to my cargo notebook. Since my account is not here, so I might not be able to do a rundown. Okay, I'll open Chrome to do that. So, but let's refresh this. Let's walk through Azure first, and then I think many of us are familiar with Cargo and Google Cloud, I guess. Right. So Azure gives you access to your choice of um, it gives you access to your choice of virtual machines, right? Based on what is available in your subscription. So like I mentioned, if you're a student and you're just hearing of Azure for the first time, or you're interested in learning Azure, you can have access to $100 credits, right, to make use of Azure. So it's called the Azure for Students package, right? So once you have a valid ID with your student's email address, you can head over to Azure for Students.
Yeah,
Let me
sorry,
see.
I just sent to the group chat now. To the chat, sorry. I just sent to the chat. So
Okay, you've shared the chat. Okay, great.
yeah.
Thank you. So, you can head over to the link that is in the chat to activate that. So we head over to the resource now and then launch Studio. So scroll down and launch Studio. All right, so now we have our studio here. You can see so many other things here that you can leverage Azure Machine Learning Studio for, right? You have access to generative AI models here, right? For Azure OpenAI services, you need access to actually work with them, but there are so many other generative AI models here, and then you can browse the model catalog actually to see what you want to experiment with. You get me? So um, OpenAI Whisper, which does speech to text, right? Speech recognition as tagged there. So you could be speaking in a language and it translates. You can decide to translate or just transcribe and so on, and so many other things you can do. So, but let's focus on what we want to achieve with the notebooks, right? So let's say, for example, now you've downloaded the starter notebook, yes, from the repository. So let me go ahead to download, right? Permits me. Apologies. Okay, so I'll download the starter notebook here, and then we'll see how we can actually make use of it in Azure. So I've loaded this up, then download raw file, right? And let's say save. You get. So, but definitely before you're downloading, you don't even necessarily even need to download manually. Once you've cloned to your repository, you already have the notebook right in your local machine. So you can just head over here and upload. So you see, click here, upload files, click browse. Then I'll head over to download and select image classification. Right, so upload. It's as simple as that. So now, but the thing next is that the next thing here is that you don't have um, a virtual machine to run this at the moment. So you need to head over to compute, right? Once you head over to compute, select you're under directly under compute instances. That's one of the things that you can use to run your notebooks. So you can see so many things here. So choose from a selection of CPU or GPU instances. We can find with popular tools, such as VS Code, Jupyter. I mean, most of us are familiar with Jupyter. So you just need to click new here. Can name it with anything of your choice. So let's say um, this is not coming up for me yet. So, but let's go scroll through. Okay, let's see, select for more options. So you have a host of different virtual machines that you can make use of. So you can see this is a 14 gig RAM machine with 2 cores, right? And with the different prices, 28 gig RAM, 7 gig RAM with the different prices. You can, depending on what you want to work on, you can go for as large as possible that is within your resource, right? So this is 32 gig RAM and 4 cores, right? So the cores basically, represent, how do I put it now, right? For scaling, basically. So let's say one GPU is filled up or one CPU is filled up, it can add another CPU to scale up, right? You get. So this is what it basically represents. You can also check out GPUs that you might have within your resource, your quota to work with, so 224 gig RAM and stuff like that. So let's just select the CPU that we feel will be good enough. Let's select, don't think we need something heavy, so let's select this D11 version 2 and name it image um, image compute or something. Yeah, so when we click review, oh, let's not even do that, right? Let's check other things that we might need to check. Okay, idle minutes, security, and all that. So yeah, let's create. So once it's done creating, then you can now go ahead to your notebook, this notebook section, and do whatever you want to do. So while we're waiting for this to be created, I want to walk you through the second project. So like we mentioned, project 2 is focused on speech translation, right? And what speech translation basically, I mean, speech translation is as clear as the topic itself. And I'm already briefed you through it. So what we're going to be working majorly with is the translation service for Azure and the speech to text service. So when someone speaks in English, you can transcribe to text in English and then translate it from English to Yoruba or English to Igbo or English to Hausa and output it. So, right, this is the translation starter script that we have. And you can see here that you have parameters here. So you have English here, and this is French. I mean, I'm not even sure what this language represents. I can't remember. But you have this here, right? And this is how you interact with the translation service. So need your translation key. So when you create a virtual environment, for example, I would have showed you, but I mean, if I do that, you are definitely going to see my keys, and this meeting, this meeting is recorded, so that's not ideal. So, but then what you just need to do is, I mean, if you see from the git ignore, like the vem that Audion added just above it, you probably would have noticed here. Let me just head over to this. You would have seen something like .env, right? So what this basically does is that any file that ends with .env, it doesn't add it to your pull request, or it doesn't add it when you push it to GitHub, so that your secrets will remain on your local computer and won't be pushed to GitHub online. You get? So basically, I'll walk you through how you can create that key, get that key, and then interact with the translation service. And Azure is the top place that houses everything. So we'll be leveraging Azure services, Azure AI services for that. So let me see if that's started. Okay, they're still running. So I'll head over to the documentation of Azure AI. But let me just even walk you straight down to this. So click on Azure AI services, right? So once you click on Azure AI services, scroll down, you see the speech service here and see translator service here. So you can click create. So once you click create, you can set it to be in the same repository that we select, resource group as Hacktoberfest. Select the same region as you chose for your resource group, East US, let's say translation. Let's see it as available. Pricing tier, you can try this out. Use this. I mean, since you are experimenting, we're not going to use your key for deployment. So you can use the free option or the free plan available to do your experimentation. So I'm saying translation underscore Nigeria. That is also available. I think it's for Nigeria, or maybe this. All right. So we can review and create, then create. Okay. So now once this is done, you can go ahead to the resource, all right? So once you go to the resource, you can see this option here, keys and endpoints, right? If you look at the starter script that we have here, the main thing is asking for is your key and then your location. So you can see your location here, which is East US. So you just need to copy that. Let's head over to keys and endpoints, right? East US here, copy that in your script in your local machine, and you can paste since your location, you don't need to hide that, but then you can see that the key is referenced using environment variables. So you can use once you create that .env file, right? What you need to do is you can now say, basically this is what's going to happen. You have translator key, right? Does do a text here. So you do translator key equals, let's say our translator key was East US equals East US. Equals East US, right? And that works. You might not necessarily need to put in the quotes, right? This works fine too. So, but I mean, some other environments, how do I put it? Yeah, some other environment syntax need you to put this inside double quotes, right? So, but with environment variables, you don't necessarily put them inside quotes. So once you do that, you paste that in your scripts, and then you can test out. You can enter a text here. Like this is the text that is using to test here. Like this was actually gotten directly from documentation. So Azure is very, very open to how they can, to help you get started with them using their services. All this is just directly from Azure. I don't think I've made any changes, and you can see how explanatory it is, right? So you can check Microsoft Learn to also for resources that you can check, that you can use to learn about maybe translator service or speech service, right? So basically, once you get your key and your location, you can then test out, run the script. It will translate this from English to French and this language here, ZU. So you can decide to get the codes for Yoruba and English. So heading over to the documentation for the translator language support, you can see the codes here. So for Igbo, we have IG. So you, instead of having French, you can put IG. For Hausa, you have HA. And then for Yoruba, right, you have YO has the ISO 6, I think it's ISO 6391, if I'm right. Right, that's the code as um how it's represented basically. So you can use that and fill that in your scripts here and then test your code to see if the translation works. This is pretty straightforward, right? Then you need to restructure this into functions that can be called. So basically, what we're trying to do is that you make someone uploads an image, and then once the image is uploaded, the speech to text is function in the speech to text script is called, translates it to text. Transcribes it to text, and then when you transcribe it to text, you call the translation a function. Let's say you can put all this right inside a function. I think many of us should be familiar with how functions work. Basically, put all this in a function, and then it does the translation to whether English or Yoruba or Igbo, and then you return that back to the Streamlit app, and then it displays it for the user. So basically, that's how the workflow goes. So you can see how easy it is. You can check out how to leverage. The full documentation is pretty straightforward. So like if you head over to Azure AI Translator, it walks you through how to get started. But you can actually head over to Microsoft Learn, right? So that you can get maybe um, tailored tutorial on how to leverage the services, like the speech service and the translator service. So you can just search translator service here, right? And you'll find so many things here. So this is one I've completed, right? Check through any of them that you find interesting to walk through to know how to refactor your code to be able to interact between different scripts and then be used for the deployment. So let me head over here now. I think right now our computer is running. So because it's running now, we can head over to the notebooks back, right, and then open our notebook. So you can see that it has called this compute here. And then you can decide to change this, or it's recommended that you change it since you're working with machine learning um, since you're working with machine learning models, you can decide to change this kernel to the Azure ML kernel. So your pandas and most of the things that you're working with are already pre-installed. So probably maybe it's just TensorFlow you need to install, pip install TensorFlow or whatever the exact calls are, but most times it's going to be pip install whatever the library is, and then you can run this on the cloud without affecting your laptop in any way. So I hope I've been able to answer your question as regards this. Um, before we go on, before we end this call, I'm not sure Felix is on the call. I'll do a very quick rundown of Project 3, right? I'm sure it's something that I'm usually very familiar with. So what Project 3, the aim of Project 3, like I already explained before, is to build a GPA prediction model for the year one performance of Nigerian students based on different things, right? So, for example, based on their JAM score, their gender, their eating habits and different things like that. So this doesn't start a notebook of how you can work with that. Of course, you need to install dependencies. So scikit-learn, I think many of us are familiar with scikit-learn, right? Or you could make use of light GBM or XGBoost or whatever sophisticated machine learning models you want to use. You can even go ahead to use deep learning. But that might not really be necessary because the data for training, tabular data are usually not very large compared to like images, like pixels and videos and stuff like that. You get me? So If you're familiar with Python, these are like things that you might like some columns in the data that you might see that are redundant. So because it's anonymously collected, yeah, right. So you most likely be saying name, anonymous, email, no, and probably just start completion date. But before we even give this, I would have cleared all those columns so that you don't necessarily have to do all this because it's basically redundant. You don't need all this. I mean, for most data sets, you won't see start dates, completion dates of the form when the person filled and when the person modified or anything like that. So this is just basically showing you how you can drop columns that you don't know and you no longer need. You can check out categorical columns, right, by selecting, based on the type. Also, whatever encoding you want to do. So like, that we're talking about grades now, wire grades. So you want to maybe rank it in a way, right? Let's say for your encoding, you want to make A to have the highest score because definitely A is greater than F, right? So maybe you want A to be 6 and you want F to be 1 and stuff like that. These are things that you can work on. Like we said, this is a starter notebook, so not exactly. So you can see that F here is 6. So just your own discretion and how you want to build your machine learning model, right? So this is a rundown um, of you doing some feature engineering. So let's say you have this CGPA year one and the grading system the person has, then you want to normalize it. So instead of having 4.75, you want to do 4.75 divided by 5 and get it all over one. So for others, people that have their GPAs and different scales, so let's say they are using a 4-point scale in their school, like most schools in the US do. So like you have a 3.0, right? So by the time you're normalizing that, that'll be 3 over 4, give you 0.75. And that's the same thing as someone that has a 3.75 in Nigeria, or let me say in most in 5-point scale schools, right? Schools that use up to 5-point scale. So these are some feature engineering stuff you want to do, right? And we're going to be using the normalized for training because imagine someone fills in the data where his grading point system is 10 scale and another person is 5 scale. If you compare it, someone might be on a 5.0 and another person is on a 10.0 in his own grading system. The model will recognize the person with 10.0 as higher, right? But it's not higher, they're actually the same. So that's why normalizing it is usually, normalizing it for this grade point average, right, is what is going to be used to, evaluate the model. So you can see a basic model here with linear regression. You testing out your model, checking the R squared error, root mean squared error, RMSE basically. So what RMSE measures is the square of the errors, right? So let's say, for example, the person's GPA from the data set was actually 0.8, but your model predicted, like that's the normalized one, right? So 0.8 out of 1 on a 5-point scale is 4.0, you get. So let's say you now predicted 0.7 for the person, meaning predicted that the person had a 3.5, right, instead of a 4.0. So the error will be 0.8, that is the actual one, minus 0.7 squared. So that's 0.1 times 0.1, that's squared. Then the square root of that, you get. So that's how the RMSE works. So the square of this the roots squared of the errors, basically. So if you take a mean of all the errors, right, all the squared errors. So let's say you have for your prediction is predicted, like let's say your test data had 100 samples, right? And then you had, let's say, 0.2 difference in all of them. So it's going to square all of them, add everything, and take the mean. So divided by 100 of the squares of all of the errors, and then find the square root of them. So that's how the root mean squared error works. And that's the evaluation metric we're going to be using for measuring the performance of your model. So yeah, happy hacking. Um, I hope I've given a thorough rundown of this challenge and what's in it for you. There's a lot of learning to do, and then we've made it as beginner friendly as possible, I believe. And I hope you find it very interesting to contribute. Um, don't forget, documentations are there that you can contribute to, so it doesn't necessarily have to be technical. We have and data collection for project one that you can participate in, right? So you see some of the images here that people have uploaded, right? You can contribute. So this definitely is a bungalow taken by someone. So you can contribute um, in numerous ways, whether with code, writing, and for our leaderboard, right? We're going to open source our designs for leaderboard. We have our design team, but any designers are open to actually contribute their designs for the weekly leaderboard. So you can follow up on the leaderboard here. It shows you the top 10 here. But for the full leaderboard, you can head over to this file, leaderboard.md, and get a full list of contributors to do your design, right? And then by the time we're done collecting data for the GPA, we're working towards opening a challenge for data analysts on Twitter, where you analyze data, analyze motive, or okay, I won't say motive, but like things that you can use to measure why students maybe perform better than others in their year one based on metrics in the data set. And then we're going to pick the best analysis based on interactions and based on how clear the analysis and how um, impactful, yeah, let me say that the analysis is. So yes, that's um, all at the moment. Any more details will be communicated to you. We have our community group chats here. Right, so you can head over to this file. So for the different schools, these are the group links that we have. We'll add more as time goes on. And you can follow this link to join the official support group for this challenge. So everyone is welcome to join the WhatsApp group through this link. We'll be sharing updates there and details of how you can help contribute, and whatever support you need, you can ask on here, or you can also have ask in the repository, probably on issues or comments and what have you. Um, Thank you very much for having us. I mean, for staying up to now, for I don't know, banking with us, whatever um, language or terminology you're familiar with. And we're hoping to see your contributions soon. So thank you once again. This is the link to the repository. It has been dropped in the chat. And if you have any questions as regards how you can contribute, we're very open to that now. Audion is also ready to take your questions on how to set up on your local machine. If you have a question, you can go ahead and unmute. If you want to drop it in the chat, that's fine. Or you have a contribution to make, maybe you think what we're doing is it's nice, or you just want to like, say something about it, we can go ahead and unmute also. Thank you. Okay, so I can see some questions on the chats from Damilare. Do you mind sharing what you mean? You said you have not seen your hackpack folder. Do you mind unmuting and maybe talking about what you mean, or maybe sharing your screen and see how we can help? Can you hear me? Can anyone hear me?
Yeah, sure, I can hear you.
All right. Okay. So yeah, Damon, I don't know if you're still on the call. Or probably maybe you are not. Um, okay, Mangong just shared something. Thank you very much. Said the projects are so amazing and challenging at the same time. We're happy to try it out. Sure, we are here to help, and whatever questions you might have, whatever resources you think we can help you with to get started, we're definitely here to help you with that. We've tried to make the repository as beginner friendly as possible, and to construct projects that the community can relate to based on tutorials you've taken and things you've worked on. So we believe you'll be able to make meaningful contributions to this project and help you get started or continue contributing to open source. And yes, the meeting will be available. The recording will be available to everyone. It will be shared also on our socials, and then we'll make a link to it also in the GitHub repo, so you can have access to it and check through. Thank you very much for making our time to join us. Um, enjoy the rest of your evening for us here in Nigeria, and wherever you are, enjoy the rest of your day. Um, we hope to see your contribution soon, and be glad to make your pull request. Thank you very much, and bye.